So the next limits we're going to look at are limits to positive or negative infinity, which are just the end behaviors of the graph. So what you want to look at are the horizontal asymptotes. It's where the graph is leveling off on the left side and the right side. So there's three ways this can turn out. And you did see these in pre-calc, but I'm just going to go over them all again to review. You want to compare the powers of the numerator and denominator, which is the degree, the highest power. And I kind of refer to this as like who's in charge of the numerator and denominator. So if the numerator degree is smaller than the denominator, you automatically level off at 0. That is just your answer. There's almost no work for these problems. You just kind of write the answer. If the degrees are equal, then as a tiebreaker, you use the leading coefficients. I think that's everybody's favorite version because you just use whatever numbers are there. And if the numerator degree is bigger, you don't have a horizontal asymptote, you have a slant asymptote, which means the graph either goes up or down. And at that point, you just check positive or negative for what signs you end up with, kind of like when we were checking the asymptotes before. And you will get either positive or negative infinity. And if you get stuck, then you have a 50-50 chance of guessing it. So looking at this one, limit as x goes to negative infinity. And again, if it's positive or negative infinity is when we go to comparing the powers. So in the numerator, this is the term with the highest power, and I'm going to ignore everything else. And in the denominator, this is the term with the highest power, and I'm going to ignore everything else. So the powers are the same. I'm going to use the leading coefficients. That is really all there is to this. So I'm going to speed this up and kind of hopefully go through these quickly. Stop me if you have a question. In the numerator, the x is the most powerful term, and in the denominator, it is the x cubed. So since numerator is smaller than the denominator, it is automatically 0. Here, the 5x cubed is in charge, and down here, it is the negative x squared. Remember, the negative goes with that term. It's like there's a -1 coefficient there. So since the numerator is bigger than the denominator, it's either going to be positive or negative infinity. You just have to check the signs. Now, you can't plug in infinity. That's not a thing. But just imagine plugging in a really big positive number, and we're just checking signs, positive or negative. If you have a really big positive number and you cube it and multiply it by 5, it is still going to be positive. And then down here, if you take a really big positive number and square it, it's going to be positive, but then we're going to make it negative. So we have a positive over a negative, so negative infinity. So again, at that point, you are just testing the signs to see what you get. So here, x to the 4th is the most powerful part of the numerator. X squared is the most powerful part of the denominator. We're approaching negative infinity. So just imagine plugging in a really big negative number. If you take that really big negative number to the 4th, it's going to turn positive. And if you square it, it is going to turn positive. So positive over positive is positive infinity. So for this one, x is in charge of the numerator. Square root of x is in charge of the denominator. So this power is 1. This power is 1/2. So the numerator is bigger than the denominator. And so we're going to have a slant asymptote. So again, we're just checking if it's positive or negative infinity. So if you plug in a really big positive number, this would be positive. If you square root a really big positive number, it would be positive. So both of these would be positive, but then we make it negative. So negative infinity. For this one, this is really 4x to the nothing. And then down here, we've got 3x squared. So the numerator is smaller than the denominator, and it is automatically going to be 0. For this next one, I'm going to use a log property. Every time I bring up log properties, everyone kind of just stares at me. You did learn them in pre-calc. This happened before we were out for the year. You'll have to let me know if this seems sort of familiar. You are allowed to take the exponent and write it out front. Any memories of that? Being able to take that exponent and move it to being the coefficient? It happened, I swear. Does anyone sort of vaguely recall that from last year? It is a thing. I'm not just like making it up as I go along, right? I'm going to take that 3 and put it out front. So in the numerator, we've got this 3 ln of x. In the denominator, we've got 1 ln of x. So since they're both ln of x, that's a tie. We're going to use the coefficients, which are 3 over 1, which would be 3. Right here, we've got the 3x squared in the numerator. Down here, is it the x that's in charge or is it the ln of x? Well, let me go back. I wrote this on here for you. An exponential grows faster, which means it's more in control than a polynomial, which a polynomial is x squared, x cubed, x to the fourth. That's what a polynomial is. So an exponential is more powerful than a polynomial, which is more faster than which grows faster than a logarithmic, which would be like ln of x. So down here, the polynomial x is more powerful than the logarithmic function. So that's the order of like who's in charge that they're gonna go in. All right, so numerator is bigger than the denominator. That means a slant asymptote. If we think about plugging in a really big positive number, the numerator will be positive, the denominator will be positive, and so this will be positive infinity. All right, for this next one, the 2x is in charge, and then down here all we've got is ln of x, so that's it. A polynomial grows faster than a logarithmic. So if we're comparing the degrees here, so to speak, the numerator is bigger than the denominator. So again, it's going to be a slant asymptote. And if you plug in a really big positive number, this would be positive and this would be positive. So positive infinity. All right, for this one, cosine of x looks like this. Do we remember this? That is what cosine of x is going to look like. It is stuck in between -1 and +1. The only values you can get for cosine are in between -1 and +1. So what I mean is they are very, very teensy tiny. They are very, very, very small numbers. They are stuck between positive and -1. So this is between -1 and +1. Down here we have x. We're going towards infinity. So, again, you can't plug in infinity, but imagine plugging in a really, really, really gigantic number there. So you have something really small, like between -1 and 1, over like a trillion. What you end up with is something like this. And I could keep on going forever and ever. What is this really, really, really close to? If you have like 1 bajillionth. I was going to wait and see if anyone else answers too, but yes, Abby, you are right. That is very, very close to 0. If I offered you like 1/1 trillionth of a slice of cake, you would be like, gee, thanks, Miss Cole, because that's nothing. So if you end up with something really small over something really enormous, it's going to go to 0. All right, for the next one, the 4x cubed is in charge of the numerator. The e to the x is in charge of the denominator. Remember, exponential is more in control than polynomial, or more powerful than. So again, we end up with a situation where the numerator is smaller than the denominator. This is growing so much faster that we get a situation like this, 1 over a gazillion, and so this is going to go to 0. And then this last one is the exact same as this. The only thing I changed was I made it negative infinity instead of positive infinity. What that does is it flips the e to the x. Having a negative exponent is going to reciprocate that. So now instead of being really, really, really important, it's really, really, really unimportant. We've reciprocated it, and that is going to not be significant anymore. Okay. So in the numerator, we've got the 4x cubed. In the denominator, we've got the -7x cubed. Those powers are the same, so we're going to use the coefficients with them, and so this will be -4/7. So these are kind of like no work problems. I didn't really do any steps for them, but you do have to remember what's in charge of what. For this last one, just to explain that again, if you have negative infinity instead of positive infinity, let me just grab another piece of paper. So e to the x, if you plug in a very large number there, you get a very, very, very large number. Okay, that's going to like head towards infinity. Or you can think of the graph is headed upwards. But if you do e to the negative x, that flips that. So you end up with like 1 over, I don't want to write 1 over infinity because that's not a thing, but 1 over like the biggest number you can think of, that's going to go to 0. So I just kind of scratched it out in the problem because it ends up being nothing. All right, so those are your limits to positive and negative infinity. Then we're going to look at the ones involving trigs. This is going to use your unit circle. Here we're going to just plug in 3. That's going to give us sine of pi over 3. I know you're like, oh no, not this again. It's going to be all right. Pi over 3 is in the first quadrant. Across from pi over 3, you will have square root of 3 over 2. That means this side has to be 1/2. And sine is the y value, which is this side. So our answer is square root of 3 over 2. So this is where evaluating trig and the unit circle comes into play in calculus. Here we're going to plug in 4. I know it says from the right, but it doesn't matter. Just try to plug in 4. That gives you cosine 4 pi over 3. So 4 pi over 3 is in the third quadrant. Again, across from pi over 3 would be square root of 3 over 2. That means the other side's 1/2. We're in quadrant 3, so they are both negative. And cosine is the x value, which is this side. So that would be negative 1/2. And here we're going to plug in 5 pi over 6. So this is just secant of 5 pi over 6. 5 pi over 6 is in the second quadrant. Across from pi over 6, you have 1/2. That makes this side square root of 3 over 2, and it will be negative. Secant means you're going to reciprocate the x value, so we are just going to flip this over. It will be negative 2 over square root of 3, and when you rationalize that, you get negative 2 square root of 3 over 3. So those are basically just a review of the unit circle. These next two are just properties that you have to remember. There's only 2 of them. If you see limit as x goes to 0, sine of x over x, that is going to equal 1. It's just true. If you look at it on a calculator, you will see that that limit goes to 1, and you just use that property when you're doing other problems. It would be the same if you had it this way. That's also going to be 1. And also it would be the same if you wrote it this way. That would also be 1, because cosecant is the reciprocal of sine, so this means the exact same thing. So all of those are like identical statements. This one, if you see limit as x goes to 0, 1 minus cosine of x over x, that equals 0. Again, if you look on a calculator, it is just true. And so we're going to use these properties when we do some other problems. This one is nice because if any part of the limit goes to 0, the whole thing goes to 0, because 0 times anything is 0. So this one's kind of nice if it shows up. So when we look at this problem, this is the part that is the property, sine of x over x. That whole part is going to go to 1. So we end up with all of that going to 1, and then we still have the 3 in the denominator, and so the answer is 1/3. So again, you have to know these, but one of them's 1 and one of them's 0, so it is not too bad. All right, here it is sine of 5x, and I can't change that. That's sine of 5x. So I need for there to be a 5x in the denominator as well. So what I'm going to do is multiply both of those by 5. So that is going to give me limit x goes to 0, 5 sine of 5x over, and then I have 5 7 times x. I'm going to write that like this so that you can see the part that goes together. This part is following that property, and so that part is going to go to 1, and then times 5/7 would just be 5/7. And I usually at that point get asked, well, hey, can't you just see the 5/7 here? I mean, like, yeah, but that's not mathematically why it worked out that way. So I still like to do the problem. But yeah, the answer did just come out to 5/7. This one, we're going to need to factor to be able to see the property. I can factor a sine of x out of both of these. So if I take out sine of x, I will be left with 1 minus cosine of x. And then in the denominator, I've got 9x squared. I'm going to write that like this. It means the same thing. I just want you to be able to see the property, 1 minus cosine of x over x. That part is going to go to 0. So it really doesn't matter what the rest of this says because 0 times anything is 0. And that's what I was saying about that one is when that shows up, that's nice. Your answer is just going to be 0. All right, for this one, we are going to plug in pi over 2. You know what, let me just draw a unit circle real quick off to the side here because we're going to need it for the next couple of problems, and then I'll have it drawn here. So pi over 2 is up here at the top. Cosine is the x part of that, which would be the 0. So we end up with a value over 0. Remember, this means that there is an asymptote. So we're just going to check which side and see if it is positive or negative. We're approaching pi over 2 from the left. What I would do is just draw a quick sketch of cosine. Cosine starts at 1 and then does something like this. It's going to be a wave. So this is pi over 2. If we approach that from the left, this is the left side, those values are above the x-axis. So they are positive values. They're above sea level is what I always call it. So we get a positive there, and 4 is positive, so positive over positive is positive infinity. But if you got to the 4 over 0 and you felt stuck, you could guess positive or negative infinity. You have a 50-50 shot of getting it. If you realize there's an asymptote, you know it's going to be one or the other. And if you were like, hey, I need another example of that, here you go. I'm going to do another one, okay? For this one, we're going to try to plug in pi. Here is pi, right here on the unit circle. Sine is the y value, which would be 0. So we end up with -2 over 0. And then I know that's an asymptote. So if you wanted to just guess, if you felt like you got stuck, you could guess positive or negative infinity. But let me graph sine. Sine starts at the origin. Cosine starts at 1, sine starts at the origin. That's how I always remember them. And then does the wave. So pi would be right here. And we're approaching it from the right. So this is the right side of that value. And those points are below sea level. They are below the x-axis, so they are negative. So I'm just going to put a little negative there. And then a negative over a negative cancels, and that will be positive infinity. So again, for this one, we're just going to try to plug in 0. 0 pi is right here. Tangent is y over x. So 0 over 1 would just be 0. So you end up with ln of 0, which you cannot do because the graph of ln has an asymptote in it there. So what is happening as we get closer and closer to 0? Well, the graph is going downwards, and so our answer would be negative infinity. So that is why it's so good to know a little bit about what these graphs look like and why you need the unit circle in case they throw something like that at you. All right, and then the last thing we need to look at are the piecewise ones. Again, these look scary, but are not difficult. I broke this function into like 5 different pieces here. All you have to do is figure out which piece of the function you want to plug into. That's really it. You just make a decision about which piece you're going to plug into. So this first one, we're doing x going to -3. You just have to figure out which section -3 lives in. -3 is less than -1, so that would be the first section. So just plug -3 in right there. -3 squared would be 9, so this is going to be 1/9. That's really all it is. You just pick which section it belongs in. So here's 5. 5 is bigger than 2, so I'm going to plug 5 in right here. 5 minus 2 would be 3, squared would be 9, so -1/9. This one says we're approaching 3/2. That would be 1 and 1 1/2 is going to be in this section, so we're going to plug in right here. So if I plug in 3/2 plus 1 would be 5/2. Or you could put 2.5 or 2 and 1/2, whatever suits your personal preference. Now these next three kind of go together. We're going to approach -1 from the left, -1 from the right, and then -1 over all. Now -1 is a place where it's split. So if you want to do -1 from the left, you want to pick the left side of -1, which would be this one right here. So if I plug -1 in here, -1 squared would be 1, and 1 over 1 is 1. If we want to do -1 from the right, I'm going to use this section, where all the numbers to the right of -1 are. If we plug in -1 there, well, there's not even an x to plug in a -1. Your answer would just be 2, since that's a constant function. And then when you do limit as x goes to -1 overall, you don't even really need to look at the equation anymore. If the left side was 1 and the right side was 2, that means they did not come together. And so the overall limit is going to have to be does not exist. Now these three, we're going to do the same thing at +1. So we want to do +1 from the left. That would be this section right here. If we want to do 1 from the left, we want numbers smaller than 1. So that is going to be 2. 1 from the right would be this section. We want where x is bigger than 1. So if you plug in there, 1 plus 1, 2. And then for the overall limit, you kind of don't need to look at the equation. If the left side was 2 and the right side was 2, then they come together and the overall limit is going to be 2. And I know some of you are thinking, but hey, at 1, the actual value is 3. That's because this is what happened. The actual point was at 3, but the limit was at 2. Both sides came to 2. So that's why all of these are 2. And then these last ones, we're going to do the same thing with 2. 2 from the left, right, and overall. So 2 from the left would be this section. If I plug in 2 there, 2 plus 1 is 3. If we do 2 from the right, I want this section. If I plug in 2 there, 2 minus 2 is 0. So I end up with -1 over 0, which means that there is an asymptote. And so I'm just going to test a number bigger than 2. So if we test 3 here, that denominator is going to be positive. A negative over a positive will be -infinity. And then for the overall limit, well, the left side went to 3 and the right side is going to -infinity. So this is going to have to be does not exist.